Well, hello, ladies and gentlemen. Mr. Yurko here, and today we're going to take a look at cookies. Well, cookie cutters, and we're going to try to understand how much stuff goes in here. I like cookies. You probably like cookies too. And if I want to bake a batch of cookies, sometimes I want to know how much dough I'm going to need for my cookie cutter, because if this is my dough, my ever so tasty dough, I want to, and I'm planning for my party, or if I'm running a bakery, I want to know how much of this I need to make enough of this to get some to all my friends. For the demonstration, just understand that my cookie dough is not the most disgusting, weird gray cookie dough there ever was. I'm actually using a piece of clay because that's what I had available and it works. But you get the idea. Feel free to eat and enjoy if you really want. So first we got to understand a couple of basic concepts. Those concepts are area and volume. Area is how much space on a 2D plane something takes up. So you're thinking things like carpet, paint, I don't know, boogers on a window, whatever. But that's area. And the formula for figuring out area in many situations is just length times width. So you figure out how long something is, how wide something is, you multiply it together, you get a number, and the units is going to be in whatever that unit is, and we're going to write that with a 2 above it, units squared. So if it's 3 feet long times 3 feet wide, it's going to be 9 feet squared. Volume is how much space something takes up in 3D space. What's the difference between 3D space and 2D space? Well, 3D space, I'm going to just use space and space together. Wow, this is redundancy. Never use a word to define that word, right? Okay, well, volume is things like a gallon of milk. That gallon is how much volume that takes up. Everything that you actually encounter has volume. Even that paint on the wall, I mean, it has volume. We just think about it as being flat. In reality, there's pretty much nothing that only has area. But if something is really consistent, like paint, which we put on a consistent thickness, we don't care about the volume. We just care about how much coverage it needs. But the reality is, most things we think about volume, how much three-dimensional space it takes up. So a gallon of milk, a can of Coke, those are volume measurements. They may not be super technical volume measurements, but they are volume measurements. And that cookie that you're going to make, or that cake you're going to bake, or the gallon of gasoline you're going to buy for your car, those are all volume measurements. And volume is also can be described as the length of something. TH, if I spelled correctly, here go. Times the width of something times the depth of something. And volume measurements are described in that unit times itself 3 times, so we call that cubed, unit cubed. So if, for example, if it's an inch that we measured, and we have inches times inches, that's inches cubed, or cubic inches, or feet, or centimeters, so centimeters cubed. So there's also specific volume measurements, like already described, gallons, liters, milliliters, stuff like that. All right. So, what the heck are we going to do about it? Again, back to my delicious pile of clay. No, don't eat that. All right. So, let's say I've got a cookie that is rectangular. And my cookie is 1, 2, 3, 4 units across, and 1, 2, 3, 4, 5 units up and down. The area of this cookie is going to be 4 times 5, 4 units times 5 units equals 20 units squared. I'm just going to put U for units, because it really doesn't matter what the unit is. So 4 times 5 is 20 units. And we can check that. We can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. So 20 units squared. And that's the area. Now, if that cookie had a depth of 1 unit deep, we would take the volume, which is going to be equal to our area, times our depth, which was, there was our area, 4 times 5, which was 20 units, squared, times our depth, in this case 1 unit, which is going to be equal to 20 units times 1 unit. 20 units squared times 1 unit is going to give us 20 units still, because 20 times 1 is still 1. I mean, still 20. But now our units are going to be squared times single, which we just add the exponents in this case. We have cubed. All right? So we have 20 cubic units for our volume. So here we have the depth. So it's 20 across times 1 deep. 20 units cubed. Now, what if we have something, and that's really easy for regular shapes. But what do we do when we get irregular shapes, like this panther or this major award? Well, earlier we said that volume is length times width times depth, and that area is length times width. You notice that area here is defined as length times width. Area here, volume, length times width. So, like you saw me substitute here just a few seconds ago, volume is area times depth. So if I can figure out the area in any other way, if I can find any other way to find area, then all I need is the area times the depth. So if I've got this irregular shape here that I can't just do length times width for, but I have a consistent depth, then I can figure that out. So we come in here, and let's say I trace this guy out on my doodad, and I'm going to have a really hard time doing that because it's super irregular. The pencil's not going to fit in here, but you get the idea. We'll do our best to take whatever measurements we can. And if we add up, so we can come in here and use our grid, and we can figure out, call that good enough for what we're doing here. There we go. Well, now I've got my panther, and I can count the squares just like we did before, and we're going to have to estimate as things being whole squares or partial squares. Each place there's a whole square, we have a whole unit, and if we have a partial square, we just add them up. So we can say, we'll call these two 1, 2, make that 3, 4, we'll call it 5, 6, 7, make that 8, 9, 10, 11, we'll call that 12 and a half, 13, we'll call 14, 15, 16, those two together make 17, 18, 19, we'll say this is 20, 21, 22, 23, 24, these two together make 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, we'll call these 35, 36, 37, 38, 39, 40, 41, we'll call that 42, call that 43, call that 44, add these two together make 45, these two together make 46, these two together make 47, and these two together make 48. So now this is 48 squares total when I mashed them together. Remember that a whole square was 1, and then 2 partial squares was another 1. So I have more than 48 x's here. Hopefully you can see that I got enough partial x's mashed together that it works out to about 48. So 48 squares, and then however deep it's going to be will give us our depth. So if we make it 1 square deep, it would be 48 units, square units, because each one of these is a square, times 1 deep unit gives us 48 units cubed, 48 cubic units. Now, is that the only way you can solve this problem? No. Now, if I've got my major reward here, and I want to figure out how much dough it's going to use, I can do it in a more precise way, because this is an estimate, but I could find an even better way to do that. Now I could take my dough and mash it out, and I could take and roll it to make it a really uniform depth to the exact depth that I want to make my cookie in the long run, and get my actual cookie depth and get it prepped that way. And then use the cutter and once I have the dough made and my cookie cut out, now let's get that out of here. Oh, come on. Such good dough. Yummy. Yummy, tasty dough. And there it is. So there's my cookie. Beautiful as it may be. Magical work of art. And now this is something that I can mash up and measure. And this doesn't need to be perfect. It doesn't need to be perfect at all, because the volume of this blob of dough is exactly the same as the volume of this. You're like, what? How could that be? Well, you saw me. This is the dough that came out of here. So whatever shape I mush this into doesn't really matter, because it's the same amount of dough. So I could come in here and measure that. I'm going to squish this into a cube. And if I was really precise, make myself a little die here. And now this is the amount of dough that it would take to make one cookie. And now I just go out and measure this. Dough. And I can say this dough is 1 inch wide by 0.95 inches. So it's now, my award was 1 inch wide by 0.950 inches long. Turn it and find the depth by 0.9, we'll call that 950 again. And we multiply those all together. We get our Calcumagic and calculate that. Do a little number magic, because it's a 0.950 times 0.950 times 1. It's going to be 0.9025. This is the inch symbol. Inches 1, 2, 3. That's inches cubed. So we're at about just under 1 cubic inch of dough to make my major award. So those are a couple different methods of finding the area and volume for our cookie cutters, depending on the types of shapes that you're working with. Hopefully this has been a valuable piece of information for you, and you'll be able to go create major, cool, awesome stuff. Go be awesome, as always, and keep being yourself.